877-2240, and I will try to get them as quickly as possible. Text messages that come through, the first one this morning, we can look at that tomorrow morning as well, around 8:30. Also know that tomorrow morning, some stuff that I'm doing before school with meetings and different things, and so just remember that going forward. All right, we're live. Let's get it rolling. Let's get it underway. So I'm going to pull up the TI Inspire. I just have this feeling like a ton of people are going to show up today. I don't know why. I guess I just think in that way. I'm not sure. It's either a ton are or none are. And right now, it says that there's 0 viewers right now, so I'm feeling good. But again, those that are coming in from Sweden, hope you're doing well too. Those that are from Oshkosh in Sweden, thank you for showing up today. Very much appreciate it. All my YouTube followers out there. Couple things that I want to note with you real quick before we get into the heart of everything. Some things that we really want to make sure we look at before the test tomorrow. First thing is this, number one, remember that for my class, and those of you who are in Miss Allen's or Miss Lauren's class tonight, welcome as well. But for those of you who are in my class, remember that law of sines and law of cosines is applied for the first part, whereas the second part will be vectors. So here's how it will work. First part, you get a chance to study. Really, to be honest, you'll probably take this pretty quickly, to be honest. But then you would have another chance to study, and then you'll take the vector portion and then kind of go from there. So that's kind of what the idea will be there. That's kind of the thought process in going to it. So we have number 1 and number 2, but it all will be in one block period. Okay, everything's in one block period. So just so you know that going forward for tomorrow. Again, please feel free, check out this podcast. That'll be huge there, and then we'll get underway. All right. So here's the thing. I have there's a ton of people on tonight, and I love it. All of a sudden, my phone blows up. I love it. Love it, love it, love it. Love when people take and own what's going on, all right? All right. By the way, it's been a great day. Just so you know, I got to see my wife in between. Man, it's a good day. All right, so let's go to number 15. Coming live to you, number 15. If you scroll down, and good night, you are just starting out with a bang, aren't you? And alive. Okay, so here's what I'm going to do, okay? I'm actually going to screenshot this document, and that way I don't have to write as much, and I'm just going to drag and drop this thing over to this side because I think that will help us moving forward. Let's see what we got. Beautimus. Let's see if it's there. Excellente. All right. Number 15 is a doozy. All right. There's just nothing else to say about it. It's just a doozy. Now, when we do this, the one problem that I'm going to give you, the one formula on the bearing section I'll give to you. And by the way, side note, law sines and cosines, but the other formula that I'll give you, only one with terms of bearing, is the plane plus the wind equals my ground speed. Now remember that when we're talking about a plane, right? So here's a plane. All right, there we go. There's the window, and there's me right there. Okay. Decides that he's going to look up at the plane. Now, remember, the plane thinks it's going in one direction at a speed, whereas the wind may affect it in a completely different direction. So what it thinks it's doing and what the ground speed is, or what it's actually doing, are two completely different things. So we say the plane plus the wind actually equals what I see on the ground. Okay, so that's kind of what we're doing. So in doing this, the first thing I want to do is label what I know. Sorry, I had to get some water. So first thing we know is 540 miles per hour at a bearing of south 36 degrees east is what I would use to be able to plug in. So remember, the plane, meaning the P over here, is south 36 degrees on the east side. So 36 degrees would be right there, all right? Notice I never use the 36 degrees. I always use the angle that is associated with the x-axis. So I'll use 54 instead of that 36 there. So in order to find this vector, vector v we'll call it, we have to figure out a way to where we get this in terms of I and j, or in terms of our vector. And we're going to come back to that in a second. But we know that step one, and I'll give you these steps on the test, is we want to graph it, okay? Graph it. Step two, we want to get it in terms of I and j, okay? Step three, we want to find resultant. That's a good word. If you want to get a good prom date, just use resultant. Actually, the resultant of the problem is actually quite amusing. Number four, we'll use magnitude. And what's number five? Those of you who are watching Dora the Explorer, yes, you are very right. We are going to find direction. Direction. All right, so first step is graphing it. So we've done the first one with the P. Now we've got to figure out what the next one is. Now, if they give me what the W is, the wind, then we would use that one. But however, in this one, we're giving ground speed. So in the ground speed, and oh, by the way, remember, this 540 is this distance here. It's the vector. 540 miles per hour is the vector, the magnitude. So when they give us that 500 miles per hour is the magnitude, remember, for ground speed, that is the distance it travels, or in this case, velocity. That's again, the magnitude. We then graph it at south 44 degrees east. So we go south 44 degrees on the east side. Notice if that's 44, we know 90 minus 44 gets me 46. So just like beforehand, we've got ground speed and plane that is graphed right there. Now the question becomes, what is I and what is j? That's a very, very good question. So in order to figure this out, what we're going to do is we're just going to put sine and cosine in down for both of them, okay? So again, we've already done step one. We've graphed both of them. Now we've got to get them in terms of I and j. So in doing that, what we have to do is with the sine and cosine, we know that the magnitude comes out on the outside, right? And what follows the sine and cosine? This one will be 500, by the way. Well, remember the angle associated to the x-axis is what we use. So this would be 54, 54, and this would be 44 and 44. Now remember that sine is corresponding to the opposite side, or y. Therefore, we think of j when we talk about sine, whereas with cosine, we think of I. So we look at it there, and when we plug it into our calculator, you'll notice that 540 sine of 54 is 436.87 j. Cosine of 54 is 317.40 I. Now, I know what you're thinking. Coach, why in the world is 436? I want you right now at your house to yell at the screen the answer of why this one's negative and this one's positive. Okay, yell at your screen. People think you're crazy. It's okay. It's okay. Very good. It's because this j goes downward, and so it won't always be the case. You have to look to see I goes to the right, therefore it's positive, and j goes down, therefore it's negative. So as I come here, same thing. 500 cosine of 44 is 347.33 I. And 500 sine of 44 is 359.67 j. Because j goes down, we know it's negative, and because I goes to the right, we know it's. So now we've got two vectors. Again, you could call it whatever you want. You could call it. Literally, you could call it anything. V U. We could put a Michigan M there. Your mom. Anything you want there, you can put there. Okay. So what we're going to do now is we're going to try to solve for the wind, because as we go up to the top, we notice what is the nearest degree and magnitude of the wind. If you have to, when you go to the problem, go to solving for. Well, since we're solving for W, we have to get W by itself. So we're going to subtract P to both sides to get W equals ground speed minus plane. So once I do that, I get my ground speed, 347.33 I minus 359.67 J. And I'm literally going to subtract 317.40 minus 436.87, as you see here. But the problem is if I subtract this, which was previously, I have to distribute to both. So what was positive? So now no longer are we adding them. Now we're subtracting them and distributing. Word 9.93i plus 77.2j equals the big. So was we found what we already did that, right? Because that's what this was. We already found the resultant vector. That's the result. Where we take A and we take B, we square them, add them together, and take the square root of it as the Pythagorean. So we could take it 29.93, we square that, plus 77.2, square it, take the square root of it. When I figure that miles per hour. And again, that is the speed that it travels, or the magnitude that the wind is traveling that affects the plane to get us to ground speed. Now, again, if I were to graph this, right, as you see down here, this resultant would go to the right, 29.93 and up 17, would literally be going that way at 82.80 miles per hour. Okay. We've got everything done, but then we've got one last thing, and that's the direction angle. Now, because this is connected to the x-axis from 0, it makes it pretty easy, because what we see on x is what we get. So to find it, all we have to do is tan inverse, or tangent of x, equals opposite over adjacent. Now, how do I get that x by itself? Well, I'm going to do that tan inverse on both sides. So where when I do that tan inverse, x equals tan inverse of 77.2 over 29.93. We solve it. Once we do, we get 68.81 degrees. That right there is our reference angle, and that is the solutions to our equation. You might say, Coach, what is the part of the oh, man. Okay. Here's what we're going to do. If it's cutting in and out, gosh almighty. All right, so let's do this. All right. All right, do me a favor. If you right now cannot hear me, okay, if you cannot hear me, please make sure you text my number, this number, all right? My internet's been freaking out, and so what I want to do is make sure that I'm doing what's appropriate by getting on the internet that will work. So if you are struggling by hearing me, please, please, please text me right now. I'm going to hold off for about a minute or so. If we need to, we'll start another one, and we'll go to a different problem, and then we'll go from there, okay? I apologize. I want to make sure we're good. So what we'll do right now is I want you right now to text me if there's an issue right now, okay? All right, so I'm going to stay on here. I am still here, but if you have an issue, please make sure you text me if it is cutting in and out. If it's not, please don't say anything so that we can continue, all right? So it is better right now. Some of you are saying it's better now, and if so, fantastic. But if it's still not good enough, we'll go to a different one. So please, please let me know. Some people are telling me it's getting better to where it's not as much anymore. So please, again, help me out with that by telling me, all right? Sometimes it sounds like I'm a robot. All right, but I know so I apologize. Make sure you keep me up to date because I have no idea on that. So if there's an issue, please let me know, and we'll cut into another one, and I'll try to do something different there. Okay. All right. So I'm going to keep it in this spot in the house so we can do that there. All right. Excellent. Now we went through that one. I'm looking to see. Perfect. Number 7 is a good one. I think that one's one we want to go through together. So it's starting up again. All right, tell you what, here's what we're going to do. All right, those of you who are on this, some of you are struggling. I'm going to email out a different link. Give me 5 seconds, okay? Not 5 seconds, maybe 5 minutes, okay? I'm going to get to another one. I'll get to another podcast there, and then you can log in, okay? So just hold up just for a second, and I'll be right with you, okay? All right. All right. Tomorrow I've got a meeting, so that's why we're doing this podcast tonight. All right. So again, hold off just for a second. I'm stopping the broadcast, but I'm going to go to a different one. Stay tuned.